In MCQ 27, we're going to take a look at the different kind of reducing agent that is employed in organic chemistry and the functional group that could be targeted and the end product of reduction. Now, writing out all of the known reducing agent in organic chemistry, we have lithium aluminium tetrahydride in dry ether, followed by sodium boron tetrahydride in dry ether, a much weaker reducing agent as compared to lithium aluminium tetrahydride. And then we move on to using hydrogen in nickel at 200 degrees Celsius, as well as hydrogen platinum at RTP. Now, the following members that can be targeted for reduction includes aldehydes, which will work with lithium aluminium tetrahydride, sodium boron tetrahydride, and hydrogen nickel 200 and hydrogen platinum at RTP. And it does give us a primary alcohol upon reduction. Now, the second category over here, you have your ketones, which will work with all of them as well. And at the end of reduction, it will be providing a secondary alcohol. You have your carboxylic acid that can only be reduced by the first member to give us a primary alcohol. And alkenes. Reduction only works with hydrogen in nickel 200 degrees Celsius or platinum, and the end product is actually an alkane. So for the context of this question over here, you can also see that for the first option of hydrogen and nickel, it should be targeting alkene but not the carboxylic acid. So there is an alkane generated, but the carboxylic acid is actually maintained over here. So number 1 is correct. Now in the second one, we're using lithium aluminium tetrahydride. The alkene should not have been targeted. The carboxylic acid should have actually become a primary alcohol. We have the primary alcohol generated, but unfortunately the alkene was targeted to be reduced into an alkane, which should not have been the case. So option number 2 is out. Now for the case of option number 3, we're using hydrogen and nickel. Alkene has to be targeted to form an alkane, but my carboxylic acid cannot be targeted. And in this case, you see the formation of an aldehyde, which is actually wrong. So option 3 is out. And for the last option here, we're looking for lithium aluminium tetrahydride. Alkene should not be targeted, and you can see that alkene itself was actually intact. You still have an alkene here, and carboxylic acid should have been targeted for reduction to form a primary alcohol, which is correct as well. So the correct answer for this question here is B.